Okay, this is lesson 16. It is on doing a couple of rectifier circuits. So if you think about the word rectify, I actually looked it up on the internet to see what it says, and the main definition is to make something right. So if something was wrong, to make it right. Well, in this there isn't anything really that's wrong, but we're going to change something. And I am going to show you some things, particularly the circuits on the board. In a little bit we'll look at the circuit diagram and the circuit board. I will show you some of that, but I'm not going to show you everything that you'll see because I want you to be able to see it. But on page 136 it says draw a simple rectifier circuit. So we're going to do that. We start off with voltage in, and I may have mentioned this before, I'm not exactly fond of the words voltage in and voltage out because voltage does not go in or come out. Current actually travels, but voltage is a potential difference between two places. But the standard terminology is that for the source, you call that voltage in, and then you're going to measure something, and that's going to be the voltage out. So we're going to use our sine wave generator, and then we're going to connect down here to the ground. We're going to use a diode. This is the junction diode, the little black diode. The standard terminology and symbol for that is to show an arrow in the direction that current will actually travel, and then a little black line to show that the current cannot, it's blocking the current. So on the actual diode, this line is represented by the silver band on the end of the diode. So we go over here, come down, we have a resistor, and then we're going to look at the voltage across this resistor. So the standard way of drawing this is to have two lines there and with the little open circles, and this is called voltage out. We are going to be measuring these voltages with the oscilloscope, so not with the meter. Okay, so this is the diagram on page 136, and then I want to show you the diagram on 138. Yeah. So this has a single diode. Now the other part is called a bridge rectifier, and it sometimes has another name, but I'm not going to tell you what that is because that will give away what kind of picture you should see. So it's very similar, except it's somewhat more complicated. So we start out with our voltage in. It's still going to be our sine wave source. Then we go up and over, and I'm going to go down here to ground, and then over to about under that. Now we're going to put in some diodes. So you should have 4 diodes, and we're going to make a box here. So this is the easiest way that I found to draw this. Okay. Now we're going to put a diode on each of those, and you can just simply write down what I have. I figured out an easy way to draw the diodes and to get them pointed the proper direction is to start over here at the left with your fingers, kind of go that way like that, and then all of the diodes point that direction. So here we have a diode pointing that direction. We have a diode pointing this direction. We have one pointing this direction and one pointing this direction. Okay. So we have our 4 diodes, and I'm going to number them D1, D2, D3, and D4. Normally they're not numbered, but I refer to them in there and you need to know which one I'm talking about. So now you might say, well, how does a current go anywhere in that? And that's the whole point. We have to add something else. We're going to add our resistor. So I'm going to draw out here from this right side, and this is going to be what we call the positive side. And then this side over here is going to be negative. And we come down from it over here. And then in here we put a resistor. It's usually subscripted L for a load. It's called a load resistor. And the top part of it is connected to our positive, and the bottom part's connected to our negative. So the important feature or significant feature is this is the voltage that we want, is the voltage across this resistor. Now, the complicating factor is that if we're going to measure these things with the oscilloscope, and we are because we want not only to measure maybe numerical values, but we also want, mostly we want to measure and look at the wave patterns. So the problem is, if we were using a regular meter, we would just simply put the leads across this resistor. Well, neither side of it is connected to ground. And so you remember from the oscilloscope, you always had the alligator clip connected to ground, and then the probe hook connected to something, and that gave you a voltage. Well, you can't connect the oscilloscope ground to here and try to measure the voltage across the resistor, because you want from here to here and not from ground up to here. So we remedy that by looking at the voltage between ground and this bottom position, and between ground and the top position, and then we subtract. So on the oscilloscope, we're going to have to do several things. You're going to need the second probe, and I think everyone should have your second, have another probe that you haven't used yet. And when we look at the circuit, I'll show you some things about that. But the idea is we're going to connect this position to channel 1 of the oscilloscope. And we're going to connect this bottom position to channel 2 of the oscilloscope. So the ground in both cases is going to be the ground of the circuit board and the oscilloscope. You can only have one ground in the whole circuit, and we've talked about that before. So we have to figure out how to deal with that. So when we're looking at channel 1 on the screen, we're going to be seeing the voltage between ground and channel 1. When we look at channel 2, it's going to be between ground and channel 2. Neither of those is what we want. We want the difference in those, because if you look here, we would say I want this voltage minus this voltage. I need the difference of those. So then we figure out, well, how do we do that on the oscilloscope? Well, the oscilloscope does not have a button that says subtract. It does have, however, a button that says to add. And then we have to think back to algebra. So if we want, let's see, I wrote that out somewhere. Oh, yeah. The voltage across the resistor, the load resistor, is the channel 1 voltage minus the channel 2 voltage. But since we can't subtract, if you remember, subtraction is just a different way of adding a negative. So we put our minus sign in a different place. So we say channel 1 plus, and then we want a negative channel 2. And that will get us what we want. This plus, of course, is an add button. So there's an add, and I'll show you that on there. And then to get a negative, you need the inverse. So that's the INV button. So it makes a negative out of that. Then the add adds those two channels, and then that will show you what we want to see there. Okay, the other thing that it will ask you on page 139 is to draw a bridge circuit just like this. So you do exactly this. And then it says to add a capacitor in parallel with the resistor. Now, we're not going to do any calculations like we did before. What we're after now is to look at the effect. So when you get the wave pattern for this, the question is what effect, let's see, I need to move these over a little bit. So I'm going to put V out here is, well, okay. Let's go ahead and do this. So we're going to put V out here, but now for the other part, we're going to add a capacitor in this region in parallel. It really doesn't matter on which side of the resistor you put it. But we're going to put a capacitor, label that C. And then we have two different capacitors that you're going to use. You're going to use a rather small one, and that is going to be a ceramic, and I'll show you in a minute, one of the little ceramic kind of yellow capacitors like you've used before. And then we're going to use a larger electrolytic capacitor. Generally, the small capacitors are not electrolytic, they're ceramic of some sort. If you want a larger capacitance, then in order to manufacture those, they generally need to be electrolytic, which means that there's some chemicals inside, and you need to pay attention to the plus and minus. The ceramic capacitors, it doesn't matter which way you connect those. But the electrolytic, you want to make sure that the negative side gets connected down here, which goes over here, and the positive side gets connected up here. And I'll show you on the capacitor how to notice those. So in that last part, you're going to connect the small capacitor and see what effect it has, and then you'll take it out and put the larger capacitor and see what effect it has. And obviously, well, I'm not sure it's obvious, but the smaller capacitor will have a small effect, and the larger capacitor will have a larger effect, more noticeable effect. Now, there's one more thing that I want to talk about. In this, there are really no calculations. It's just answering some questions about the kind of wave pattern that you have. In the homework, which starts on page 141, it says to draw a circuit and show the path of the current for forward bias. Draw a line beside the circuit wires and put a few appropriate arrows on the line to indicate the direction of the current. Draw the circuit, or beside the circuit, draw a voltage versus time graph. Well, I'm not sure if that's real obvious because I've done this before in a different class, and students seem to not really understand or get the idea of what I wanted. So what I'm going to do is go back to this circuit, and this is the circuit, well, it's one of the circuits. So what I have in mind is if it's forward biased, then I would put a plus up here and a minus down here, so that it's for that instant or that fraction of a second that the current is actually going out that direction. So if this is plus and this is minus, the current is going out this direction. So then you look at the diode, and the question is, will the current go through the diode that direction? And yes, it will, because that's the way the arrow is pointing. So beside the wires, not on top of it, beside it, draw a line that goes around. So it goes around that way, it goes around, and you ignore the voltmeter there. It goes through the resistor this way, and I would say ignore the ground and draw it like this, and then put some arrows. You really only need one arrow, but it might be good to put a few more arrows to show that that's the direction of the current. Then beside this, you would draw a graph of voltage versus time, or current versus time. Either one is fine. But you would draw the graph that you already saw in when you were filling out the lab. So this would be, I would say this would be forward bias. Forward. Now, let's think about this. If you have reverse bias, and I will do that in a different color, you would put the plus down here and the minus up here. Then the question is, will there any current go the other direction? And from our experiments with a diode, we've seen that current does not go backwards through the diode, at least under normal circumstances, and that's what we have. So there is no current, so then for reverse, you would just say no current. And then, of course, on your graph, you would have a graph that just has a line on the x-axis because there is no current. Now, when you get to this circuit, I'll show you just a little bit. I'm not going to draw anything, but I'll explain just a little bit, and you'll still have to think about it when you actually draw this. You'll do the same sort of thing. So if you think about this, current can come out this positive side. When it gets to here, you look at the two diodes. Can the current come down here? And the answer is no, because this diode is blocking it. So the current will go through here. Now, will it come down through this diode? No, the diode's blocking. So it's forced to go over here. It goes through the resistor, and you don't need to do this with the capacitor, just do it with the resistor. It comes down here, comes here, goes back up here. Now it has a choice, and it looks like the current could go either direction. But if you have the current going back up here, it's just going to go here and go around like it was, or it's going to try to go backwards in the same wire that the current is going forward, and the current cannot do that. So when the current gets back up to here, its only choice is to actually go down through this diode. When it gets here, then instead of going up there and around where it's already been, it will come over here and go back up to the negative side of the source. So that would be the path for the forward bias. And then the negative or the reverse bias, you would have this side is positive, this side is negative, and you would start out and do something similar. So you can think about that. But you will need to draw separate diagrams, separate circuits. Just repeat the circuit and then show the path beside the wires that are there. Don't draw arrows on the wires that are already there. You need to show the separate path and show at least one or two arrows to show the direction that the current is going for the forward bias and the reverse bias. Okay, so now we need to look at the equipment here. I need to get my pages in order. And I think when I did this before, I was kind of over here on the side. So, because I have to be able to see the oscilloscope. So it said to set up the simple rectifier. I will show you a few of these things, but the bridge rectifier, I'll show you the circuit, but then I'm not going to show you any of what you see on the oscilloscope. So you need to follow the instructions. It's important that you read them carefully. You're going to use the function generator, so we're going to go back over here in this left region. We have the function generator that you've used before. You need to connect over to some region here to build your circuit. You need the junction diode, the little black diode, and be sure that you have the silver band pointing toward the bottom. Then you need the resistor, the load resistor. It's 10 kilo ohm. Now, you've used it in one of your other circuits, so be sure that you get the 10 kilo ohm and not the 100 ohm and not the, I'm not sure what else you have, but it should be the brown, black, orange resistor. So it goes here, and then you notice from the bottom side of the resistor it goes to the ground. So I've got the wire here from the bottom side to the ground over here, and you've used that before. So you need the sine wave, so make sure that the function generator button is on the sine wave. It's the one all the way to the left. And then you want 500 hertz. Now there's nothing in this that you need to have 500 exactly. If you want to use your orange meter, the orange DMM, and adjust it to 500 exactly, that's fine. But you can get pretty much what you need by a few adjustments up here. So this top button goes to the 1K because that's the highest. Then this left button or knob goes from 0.1 to 1. So if this one is all the way clockwise, then it's at 1 times what this top one is. So all the way clockwise would be 1 kilohertz, which is 1,000. So obviously 500 is half of that. So the easy thing to do is to just move this till it's about halfway. And as I said, it doesn't have to be 500 exactly, but we thought we would give you some number there to deal with. Okay, so then you're going to turn your circuit board on, and I already have the second probe here. These wires do get tangled if you're not careful, even sometimes when you are careful. So this is the probe that you've been using before. And in here eventually says set the sweep rate at 1 millisecond per centimeter. That's what I've got it on. Now most of these knobs, it doesn't matter exactly what setting you have them on, but these are convenient ones. And I also have the volts per centimeter, volts per division set on the 1 volt. You could have it on the half and it'd make it a little bit taller if you want. It doesn't really matter. So let's see. Okay, where do you connect? Oh, in step 4 it says connect the second oscilloscope probe to channel 2 of the oscilloscope. So find your other probe and put it here. It's not the thing in the middle, it's the one over here on the right. So you connect it the same way that you did the other one. You should make sure that the orange slider is on the ×1. You have to look kind of carefully, but make sure it's on the ×1, and your other one should already be, your original one should already be on ×1. Now, I've already connected the channel 1 to the ground, and it's not necessary to connect channel 2 alligator clip to ground because the ground is already inside and it's grounded because of channel 1. Now, what I found was I kind of felt better if I did have it connected to ground because I didn't exactly like that loose alligator clip floating around. So if you want to connect it to ground, that's fine. Okay, so we need to adjust the amplitude to get about 1 volt per centimeter. So we need to use this, and we want to connect up here toward the top of our circuit. Now this is part of the other circuit, so you want to be looking at this, the resistor and the diode. So then also this middle selector mode, you're going to use it several times. Notice that the top says channel 1, then there's a channel 2, then there's a dual that will show both of them, and then there's an add. So for right now we want to look at channel 1, and we have it on channel 1, and I've adjusted this to about one amplitude of 1 volt, so that means 2 centimeters peak to peak. You can also adjust it carefully. Again, it doesn't make a lot of difference. The overall pattern that you're going to see is what you're after. Okay, so you're supposed to put the channel 1 to ground. So see that the line is about there in the middle. Put it back down to DC. Channel 2, put it to ground. Oh, now when we want to look at channel 2, we have to move this middle one to channel 2. And it's already about in the middle. So I'm going to put this back up to channel 1, and then this has to go back down to ground, or to DC. So actually here it says that we should have these on 0.5 volts per division, so we can do that. It just makes it a little bit taller. You need to have both of these on the same setting, whether it's 1 or 0.5. You might also check to see that this gray inside knob is all the way to the right and clicked. This one should already be from when you've been using it before. Okay, so step 7 says you want to view channel 1. So that's what we're on, is viewing channel 1. And I generally in here said to sketch the pattern for three periods. That's mostly so that you get an idea. It's a qualitative sketch, so you don't really need to plot things. If you want to, that's perfectly fine. But I just kind of made a sine wave with 3 periods. Now, we're going to look at channel 2. So we have to figure out where channel 2 is connected. And it is going to be connected just to the other side of the resistor. So we're going to have it and all these wires connected to the other side of the resistor, so that this is our voltage out. We want just the voltage across channel 2. So with this one still on channel 1, this is our input voltage. And then channel 2 is our output. Now, we have to be able to see it. So what I'm going to do is move this to channel 2, and we notice that we have a nice little wave pattern that looks kind of different than what we've seen before. So you notice that you still have the bumps, but you don't have any of the negative part. You have the positive part, but not the negative part. And that's the result of the action of the diode. And there's some questions in there about why and how and all of that, so you might think about that for a little bit. Then we want to look at both of them together. Now we do not want to add them, but we just want to see both of them at the same time. So then this knob gets turned down here to the dual. So you notice that you see again what our initial one was, and then our channel 2, and that on the dual. Now we see both of them at the same time. So there's a place where you're supposed to sketch those, and it looks like this second one that has experienced the diode, it's not quite as tall as the other one, And that has something to do with the voltage that it takes to turn on the diode. So if you look back at your voltage, current voltage graph in the last lesson, you saw that it did take a little bit of voltage, perhaps on the order of a half a volt or so, to get anything out of, get any current out of the diode. So that's why this other one is not as tall as the first one. And then of course we have this where it's blocking the negative part. Okay. So that's the simple one. Now what I'm going to do is take this off of here, and I'm going to show you how to make sure that you have the bridge circuit done correctly. So what I have, and I think the easiest thing to do might be to start with the bridge part. I think I'll pull this out for the moment. See if I can remember where I had it. The diode bridge, that's the diamond shape. So you have to make sure that your diodes are pointed in the right direction. So what I did was I started over here on the left, and I decided to do it here because I wanted to leave this region for the first part. If you're done with this part, then you can take these out. You can actually put this over there if you want. It doesn't really matter where you have it. But these two are D1 and D3. The left ends have to be in the same row. Then this one I have it coming up here, and this one going down here. Then D2 gets connected to D1, and D3 gets connected to D4. Now, one important thing is that where D1 and 3 are connected in that row, that cannot be the same row where D2 and D4 are connected. I could see where if you're conscientious about building things symmetrically and making everything nice, you might start up here and put one over there and put the other one over here, and in this actually the same row, and you have to make sure you don't do that. And I even in there have a note that they cannot be in the same row or it doesn't work. So I have these two here, and then I went over to here. Now if you have removed these, you can put maybe 1 and 3 in here and 2 and 4 over here, and that would be fine. This region here is a break so that this row is not connected to a row over here. So you could use this part and this part, or as I've done, use this part and this part. You could probably even use this part, but I decided not to do that. I like putting things in rows. Okay, so once you have these 4 in there, making sure they're pointed the right direction, then the load resistor, which is the same load resistor, it's a brown, black, orange, and I think you only have one of those. I have 2 because I put one here and one here, but you would need to use that one, and you will need to use this diode that you used before because you have a total of 4. So you put it in here. Again, resistors, it doesn't matter which end you put where. So I put this one in where D2 and D4 are connected. Put it down to here, and then I'm going from there. So this is the bottom end of the resistor, and if you look at the circuit, that needs to be connected over here where D1 and D2, at the left side of D1 and D2. So I have a wire. I'm going to put it on the other side, I think. Yeah. Okay. So at the bottom of the resistor, then I'm going to connect, and it kind of goes across these. and into a hole. Get my hand out of the way in a minute. Oh, that's not, there it is. Into a hole in the same row as D1 and D3. So D1, D3, and this black wire to the ground, it's not to the ground. It's from here to the bottom side of the resistor. That has to be connected there. Okay, so now we have our bridge and our load resistor, and we have our load resistor connected where it needs to be over here. Then the next thing is to connect the function generator. So you can leave it at the 500 hertz like it was. Then you want to put channel 1. Channel 1 is going to go to what I call the top side of the resistor. So it's going to go here. You want to make sure that you've got channel 1, so you have to find it. And I'm not going to show you the pattern, wave pattern, because I want you to figure it out. Somewhere is channel 1. Anyway, I don't know. This is, okay, then that came out, so it has to go back. Make sure it's in the ground thing. Okay, so you're going to connect here to the top side of the resistor with channel 1. You're going to use channel 2 and connect to the bottom side of the resistor. And then to get what you need over here, there is an INV. It says channel 2 INV button. You have to push that. Push it and it stays in. Push it and it comes back out. So push it to stay in. That will give you the negative. And then you want to add. So this middle selector needs to go all the way to the bottom to add. And then it will add those two, which is adding the negative of channel 2. So that will actually give you a subtraction. And then you want to sketch that wave pattern. So if you get something and you're not quite sure, it's certainly fine to call me and describe it, and I'll tell you if you've got the right thing or not. Okay, then the last part of it in section 5 is to use this same circuit and then add the capacitor. So the easiest thing is, I have these removed. We've got the capacitor, the little ceramic looking one that looks like one you've used before. You simply put it in parallel with your resistor. It doesn't matter which side of the resistor you go on. Just make sure that it's in, has to be in one of the holes in parallel with the resistor. So actually, if you have your resistor kind of over here on the right, that might be the easiest. Put the capacitor there, and then you can still leave your channel 1 and channel 2 connected to the top side and the bottom side of the resistor. So that's the first one, and it will have an effect. I'm not going to tell you what it is, but in step number 3 it says to sketch the wave for 3 periods. So you do that, and then you need to use the 100 microfarad electrolytic capacitor. Now it says on the side, it says 100 microfarads. So it's this round thing. Notice that it has a long lead and a short lead, and on the side there are black lines to indicate the negative side. So on these, it is important that you get the plus and the plus and the minus and the minus. With the ceramic, it didn't really matter. So the easiest way is to kind of bend that out there, then both ends are about the same length, and then you can put it in there so that it's in parallel with the capacitor, and then you can see what effect it has, and then you can sketch the wave pattern for that. Okay, so then when you have that, then you're done with the experiment, and then you can answer the questions. So again, if you have questions, even if you think it's right, but you're just not quite sure, please let me know and I'll help you figure things out.